In part C, we extend the method to 3 inequalities, still 2 unknowns, but 3 inequalities, and it really is the same thing. We graph all 3 inequalities, including the shaded regions, and the overlapping shaded region of all 3 inequalities represents the solution set. So let's start by graphing the related equation to this first equation, or this first inequality rather. 2y minus x is less than or equal to 2. So change it to an equal sign, and we'll graph that equation. Now, probably the easiest way to graph this equation is back to using intercepts. So just make a little t-chart. If you want the x-intercept, plug in 0 for y. So this term effectively goes away. And you can see that x equals negative 2 if you multiply through by a negative. So negative 2, 0 is your x-intercept. If you want your y-intercept, plug in 0 for x. So that this guy is effectively gone. 2y equals 2. Divide both sides by 2. Y equals 1. So 0, 1 is your y-intercept. So we'll plot both of those. Negative 2, 0 right there, 0, 1 right there. And I graph the line using my line tool. And it is a solid line because of the less than or equal to. And then which way do I shade? Let's use a test point here. So let's use a test point of 0, 0. As long as 0, 0 is not on the line, it's okay to use that as a test point. So your test point is 0, 0. Do we get a true statement when we plug 0 in for x and 0 in for y? And yeah, we get 0 is less than or equal to 2. The whole left side zeroes out. We get 0 is less than or equal to 2. That's a true statement. So we shade on the side containing the point 0, 0. Next, let's graph the equation that goes with y minus 3x is greater than or equal to negative 4. So y minus 3x is equal to negative 4. Change the greater than or equal to an equal sign. And I think what we'll do for this one, we'll just add 3x to both sides. And graph this one using the shortcut because we'll have y equals 3x minus 4. So hopefully you can see that the y-intercept is 0, negative 4, and that the slope is 3. So we'll go to 0, 1, 2, 3, negative 4. And okay, a slope of 3 over 1, so up 1, 2, 3 over 1. You could also go down 1, 2, 3, and over negative 1. Because 3 over 1 is the same as negative 3 over negative 1, isn't it? I get my line tool, go through those 3 points. And once again, it is a solid line. So which way do I shade? Well, okay, you can see that if you had actually solved the inequality, you'd get y is greater than or equal to 3x minus 4. So if you use the shortcut for finding the shaded region, you would go with generally shading above the line that we just plotted. So kind of in this direction. And then we've got one more to plot. We've got y is greater than or equal to negative 1. The related equation is y equals negative 1, which you know is a horizontal line at a height of negative 1. So I'll use my line tool to plot that. And that will also be a solid line because of the or equal to part. All of these are solid lines because of the or equal to part. Okay, so which way do we shade? Well, because of the greater than or equal to, you have to shade, since it's a horizontal line, you have to shade up to get y values that are bigger than or higher than negative 1. So you don't have to think a whole lot about it other than when there's a variable missing, you're going to shade in the direction that it specifies. In this case, y has to do with how high a value is, so you shade, and it's greater than or equal to, so you shade up. So we would shade upward, and then hopefully you can see the overlapping shaded region is going to be this triangle in here. In fact, I could zoom in on it for you, and we could shade it right in here. The overlapping shaded region where you see purple, green, and red is this triangular region right here. And so what we're saying is you pick any point inside this triangular region shaded in yellow, and it's going to satisfy the three original inequalities. Okay, and just one last bit of information here. It turns out the corners of the solution regions, the corners are called vertices. I'll highlight them in blue. And those corners turn out to be important in business applications. So you won't see those applications in this class, but perhaps later on you will. And the homework then is going to ask you to find the coordinates of those vertices. So the vertices here appear to be at, let's see, probably 1, -1. I'm guessing just based on the picture. I'm kind of solving by graphing here. 1, -1 would be that vertex, lower right corner. And then upper right corner would be, it looks like it's at 2, 2. So 2, 2 for that vertex. And then this vertex over here, well, it looks like it could be possibly at -1, 2, 3, -4, -1. How do you tell for sure? Well, you could check your guess by plugging into the relevant equation. So for instance, this line in red here is given by the equation 2y minus x equals 2. And the line in green here is y equals -1. So you could check by plugging into both equations. Of course, if you plug in y equals -1 into this equation, then you get a true statement. -1 equals -1. If you plug in x equals -4 and y equals -1 in this statement, you'll get -2 minus -4 plus 4 equals 2. That's a true statement as well. So in fact, -4, -1 is the left-hand vertex here. You could check the other vertices in the same way by plugging in the relevant equations. Worst case scenario, you could solve the system of equations y equals -1 and 2y minus x equals 2 to come up with the vertices, or in this case, that particular vertex of -4, -1. But usually in the problems in the homework, you can get them just by using the graphs.